In the last video, we learned how to integrate some very basic functions that led to having ln as our answer, okay? Now what we're going to do in this is that we're going to do the same thing, but this time we're going to do it with some more complex questions, okay? So I'll do the ones that I've highlighted here. So we start with the first one, which is integral of 8 upon x. Okay, now there's a catch in this question, and that is, if you were to differentiate x, sorry, not integrate, the answer would be 1, okay? But what do we have here? We have 8 over here, okay? Now, how do you fix this? Well, there's a very simple way of doing that. So what you want to do is, before you integrate anything like this, you just want to clean this up, okay? Now, I'll tell you what I mean by that. By cleaning this up means that take all the constants outside if that's possible. In some cases, it's not going to be possible. In some cases, just like this one over here, it is very much possible. So if I clean this up, so a cleaner version of this would be that you have 8 and then you have 1 upon x, okay? So everything is just the same. The only thing that I've done is I've just taken 8 outside of the integral sign, okay? And we're still integrating with respect to x. So now what I'm going to do is I'm just going to focus on this part of the question, okay? And that is integrating 1 upon x. And we all know the answer to that. We all should know the answer to that the integral of 1 upon x is ln x. So the answer to this would be 8 as it is, and then you would have ln x plus c. And there you go. That's your answer. And that's the standard way that I want you guys to follow whenever you're integrating questions like these. So we'll do some more example questions. So let's do part B, which is exactly the same as part A, which is just a number that's different over here. So a cleaner version of this would be 5 integral of 1 upon x with respect to x. And now if you were to integrate this, so you're only worried about integral of 1 upon x because 5 remains as it is. So you have 5 ln x plus c. And there you go. That's your final answer. Okay. Now, what exactly do we do in part C? Well, let's find out. So you have integral of 1 upon 2x with respect to x. Now, if you were to clean this up, a cleaner version of this would be, so I'll just write below it, a cleaner version of this would be that you would have 1 upon 2 outside, and then you'd have 1 upon x is what you're integrating basically. So the answer to this would be 1 upon 2 as it is, ln x plus c. And there you go. That's literally it. In part E, however, things get slightly, but I repeat, it's only slightly more complex, because what you have in the denominator is 3x plus 2 and what you have in the numerator is just 1. Now, how exactly have things gotten complex over here? The differential of 3x plus 2 will just be 3. I mean, not just be 3, but it'll be 3. What we have in the numerator is 1. So this is the point where you got to think, can I turn 1 into 3 somehow? The answer is yes, you can always turn 1 into 3 by multiplying it by 3. But can I just multiply a function by 3 and leave it just like that and not do something to sort of offset the effects that will take place once you multiply it by 3? Of course you can't. You can't just leave it like that, okay? But what you should do is you should figure out a way to offset the effect. And that's very simple. If you've multiplied a certain equation or an expression by 3, you can offset its effect by simply either dividing it by 3 or multiplying it by 1 upon 3. So it's the same thing. Multiplying by 3, the opposite would be, dividing by 3 or multiplying by 1 upon 3 is the same thing, but the opposite of multiplying by 3 would be multiplying it by 1 upon 3. So what I'm saying here is that if you multiplied it by 3, so make sure that you also put a 1 upon 3 outside so that they just sort of take care of each other and the overall value remains the same, okay? Now, so what we're looking at is 1 over 3 over 3x plus 2 dx. And now I can comfortably integrate this because the differential of the denominator, 3x plus 2, which is 3, is in the numerator. So there you go. All I got to do is write 1 upon 3 ln 3x plus 2 and then put a plus c at the very end. Now, I will encourage you guys to differentiate 1 upon 3 ln 3x plus 2 and see what you get. If you get the exact same thing, that means you've done it right. If you don't, that means you've done something wrong. But anyway, there's one more part that I'm going to solve, and that's part H. So in part H, we have 4 over 2 minus 3x with respect to x. Okay, let's see what happens here. So if you were to integrate 2 minus 3x, okay, so first thing I want to do is I want to clean this up, okay? So I'm going to get the 4 outside before I do anything else. So I'm looking at 1 over 2 minus 3x with respect to x. Okay. Now what you're looking at is, you're looking at 2 minus 3x in the denominator, the differential of which will be minus 3. And what do you have in the numerator? You have just the 1, okay? So that means you got to multiply it by minus 3 so that it becomes equal to the derivative of the denominator. But since you've multiplied by minus 3, that means you got to also multiply it by, there are two ways to look at it. Either you can multiply it by 1 upon minus 3, but a nicer way of writing this would be multiplying it by minus 1 upon 3. Since minus is a sign that's always, it's always good to have it in the numerator only, but not in the denominator. So what you're looking at is minus 4 upon 3 integral minus 3 to minus 3x dx. Now we can integrate this comfortably because we have in the numerator exactly the differential of 2 minus 3x, and that's minus 3. So we'll have the minus 4 upon 3 as it is, ln 2 minus 3x as our argument, and then the plus c, and that's it. We are done with this question. So I hope that you guys have understood this concept, and that is the end of this video. I'll see you guys in the next one. Until then, take care. Bye-bye.